Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along.
Hi, I'm Brad Coogan, Editorial Director of MetalForming Magazine at the Precision Metal Forming Association. Welcome to another episode of MetalForming Live. Today we've got an expert panel of automation experts who are going to talk about the subject of automation in metal fabricating and metal forming plants from their perspectives, what they're seeing companies do, why they're doing it, how they're using everything from robots and cobots and AI and Cartesian automation systems as well. So before we get started, I want to thank our sponsors, NEDEC, Wilson Tool, and Principal Financial for supporting our event. And as always, we want your audience participation. Please ask questions of our panelists throughout the show. We want to know what you want to know, so please ask your questions using that Q&A panel on your browser. So, without further ado, we'll go ahead and have our panelists introduce themselves. Will.
Excellent. Hey everybody, I'm Will Healy from Universal Robots, Teradyne, and I have been in automation and manufacturing for nearly 25 years. I've done roles from controls programming to quality engineer to product manager and salesperson, so many different things, and I just have a lot of experience in automation deployment and have been at UR about 3 years now.
I'm Benjamin Peters, Senior Mechanical Engineer at PCR Integrated Stamping Systems. I have a background in automation, design, additive manufacturing, and CAD.
Hello, my name is Todd Wenzel. I'm with TCR Integrated Stamping Systems as well. Our company does capital equipment for metal stampers, fabricators. We're involved basically as integrators, selecting the right equipment, putting it all together. We've been implementing automation, small and large, primarily for the feeding and movement of parts through its presses and stacking of parts at the end of presses for, I don't know, a few decades now. I've never had a real job. Been manufacturing all of this.
And I'm Lou Krenz, Senior Editor with MetalForming Magazine.
And Lou's going to field your questions as they come in on his laptop over there. So thanks again to everybody for being here today. Todd, we're going to kick things off with you. And we were talking earlier about what you're seeing in terms of why companies are automating today. It might be a little bit different than what you'd seen in the past. So share some of your thoughts on what you're hearing from your customers and shops.
Yeah, there's definitely been a change in the rationale why people go into automation. Traditionally, when I was beginning my career, it was almost always focused on man count reduction and ROI, reducing manufacturing cost, right, by reducing the number of people, and it was very desirable. And that was really the biggest push that I saw. Some quality as well, but demographics have caught up to manufacturers, especially in my region of the country. I work a lot in the upper Midwest, and so as the baby boomer generation is gradually aging its way out of the working age, there's fewer people left. So people are saying, well, young kids don't want to work today. Well, there's fewer young kids, right? It's not that they don't want to work, there's less of them. Right. And so everyone I work with is really challenged with getting a team in. So automation is driving a couple things there. Sometimes people are automating projects not to reduce the number of people because they have no one else to run it. If they don't automate it, they just lose all the production. Have you seen that?
Oh yeah, definitely.
Yeah, it's a thing. And the other benefits of it too, where it extends the working life of the older workers as well if you can automate more manual tasks. So one of the things, we're going to talk largely today about robots or Cartesian welding and what you think of as automation broadly. But one of the things that's certainly been a theme in our production systems for stamping lines is automation of the setup steps. Tasks that were routinely mechanical. I'm going to loosen this bolt and I'm going to crank this up to get the pass line on my feed the right height and tighten it back down.
Right.
Well, now it's recall job 237 and the pass line adjusts, and the straightener entry guys adjust, and everything's adjusting by itself. The whole line sets itself up. It's automation of the steps an operator would normally do. So we're seeing that it reduces the amount of labor. I mean, physical work. It does make a faster setup, which is desirable, of course. It also allows the other challenge, right? If we have fewer older workers, by definition, we usually have less experienced workers. So you're taking most experienced people and they automate the setup. And now your newer operators can recall the setup and it resets itself and get a really robust setup that's stable right out of the blocks. Right?
Are you seeing those those automated feed lines replacing aging feed lines? And that's why they're making an investment, and then they decide to go with a higher level automation, or are they just?
I don't know that I've had anyone replace a coil line, for instance, purely because they would like more automated functions.
Okay.
But it becomes a routine topic of conversation when you are doing it. We more often see people replace feed lines because they need capacity to run high yield strength steel, and the old line just can't do it.
Okay.
But it becomes a conversation where how much, not if we should automate things, but how much we automate. Right? How far am I going to carry this to do that? And also another justification we see a great deal of more now is safety. So especially again, these more manual tasks, these are heavier parts you're carrying. I had a safety director for, we're gonna talk about this later about some laser part picking automation for lasers. But she knew based on how many thousand people hours of working, predictably how many accidents they're gonna have, cuts, soft tissue injuries, turns, strains of view. Again, we are seeing that. So people are looking at the safety aspect of saying, hey, if I can automate some of these functions, I'll protect my workers' health. Right. So, which changes the ROI, right? They're looking at other factors. So, I mean, everyone still wants to reduce cost.
Yeah.
Do that.
Yeah,
But I mean, these weren't even discussion points, right? And so anyway, these are definitely differences in trends.
Yeah, I think going beyond just the productivity ROI with all those other kind of softer value things that are now more important because you're trying to attract people to your organization. So
That's, you're seeing, we could say about the recruiting thing. If you bring a young person in today and the tasks are very manual, right? I've got a 3-foot wrench. I'm doing all these mechanical adjustments and doing all these things. They're like, I don't know, this is really for me, right? So they're much more attuned to having more powered functions. I mean, even the car seats you have today everything's powered on them, right? But I gotta reach down and grab the boom and move it. Well, where's that coming from? So so that actually becomes a recruitment thing too. We have technology, I have color, I have a touch screen on here. I'm real comfortable with this. Whereas our older workforce used to struggle when we bring the automation. They just wanted to push buttons and cranks.
Sure.
Right. And so I can think it's an incentive. It actually helps as you bring younger staff in.
yeah, I think all generations are more technology centric, right? So I think, lots of people wait in line. I don't have my phone up here, but like lots of people wait in line overnight at the Apple store to get the newest technology. They're investing forward. We're all investing forward in the newest thing and the newest technology. So when they come into your shop and your newest piece of equipment is from the 1970s, it becomes really hard to attract folks who are expecting like regular investment in technology.
Right.
So so it's definitely a broader number of things are going into the decision.
Do you think then, from your experience, it's easier or more common for companies to invest a little bit more and get those automated features in there?
It's certainly much more common to see that level of automation used to be. Now, to be fair, the capability of automation keeps increasing faster than the rate of the price. I mean, like I think they're more feature intensive and much easier to deploy than they used to be.
Sure.
And so the barriers to entry on cost and complexity have also reduced as software has gotten better and controls get better and they're getting crazier better now with the introduction of AI and being used on the shop floor becoming more and more dynamic. So I think it's another way that keeps it moving forward. So anyway, those are all factors that I would say that 15 years ago, 20 years ago, I wouldn't have been thinking about, just taking labor out. People weren't talking about safety as much. When we talk about safety and automation, it was just what kind of gardening to do to make sure the system is robust and safe to work around, but we weren't really thinking about the safety of the operators. And not that we're not important. I'm just saying it wasn't like a factor why we're automating. Now it is.
Especially as you said, as they're aging, you want to make their jobs easier.
We've had at least. Yeah, we've done 2 projects at least in the last several years where the parts were like 200 pounds. And they were being done manually. It'd be a 2-person operation on each side of the press to pick up these very heavy parts. And they would be sliding, they'd have guides up and they'd come off conveyor and they would slide them and it was a very heavy operation. They weren't lifting 200 pounds, but they were moving 200 pounds all day long. And, So all of a sudden, this automation comes in and can pick these big parts and replicate these things. And no one was unhappy. No one lost any jobs. They deployed in other parts of the factory and jobs that were much more desirable. So
Good.
there are some themes I think are definitely different on why people.
Okay.
Think of the other things we wanted to talk about today on that area. I think that's the biggest thing that I wanted to talk about is, in the beginning was just this general trend. I really see a different motivation why people want to do it.
Okay. Then you've got some photos and videos and stuff.
I do. I'm going to come back to that in a little bit. If you don't mind, I think I'll recover. One of the things I like to do is ask Ben to spend a little time with us. So we talked about, explain the difference between Cartesian and the 6-axis robots, but there's different types of automation and they're just different. They're different and they have different functions. And so there's not like one is better or this or the other. They have different strengths. And I was hoping Ben to spend a little time on that.
Absolutely. I have a presentation.
All right, that's perfect.
Well, yeah. A few notes. All right, I think you're dead.
I mean, while they're getting the computer running, Brad, that always happens on these kinds of things. It's like a guarantee, right? So no matter, if you're gonna talk about technology, the technology isn't gonna work. That's typically, that's what I always find.
Hey, that was
So-
by advanced security technology. It needed,
Oh, you need your finger.
You need a
Nice.
fingerprint.
Oh, okay, good.
so my biometrics were rejecting him, which they are designed to do, so.
But I just read a Deloitte report that came out in May. They do like this smart manufacturing report every once in a while.
Yeah.
And 78% of the firms that they interviewed have allocated 20% of their budget to what they deemed like smart technologies. But it's all the things that you talked about, like why people are automating. So, analytics, automation, vision, robotics, these are the top things that they're allocating budget to. So 80% of firms. So if you haven't been allocating 20% of your technology budget to these kinds of technologies, your competitors are.
And you wonder where that 20%, how much that's gonna
Leads
lead
to.
to.
And it's gonna grow, absolutely. They talk a lot about that in the report, about how that number's growing.
Okay. You ready, Ben?
I'm ready, yep. Want to see the slides?
Yes, sir.
Yeah, all right, so this is a presentation just kind of for review, for those of you who know, and as an introduction for those of you who do not. A Cartesian robot in general are 3 orthogonal axes that can move an object in 3D space, while a 6-axis robotic arm is a cantilevered arm with stacked axes, each on top of each other, to afford full 6 axes of motion. Of course, the degrees of freedom of a 3D object in space is 6 axes. So in general, if you're using a Cartesian robot, 3 of those axes are unconstrained. This is kind of reviewing what I just said, comparing the 3-axis versus 6-axis. But of course, you can have a Cartesian robot that moved in more than 3 cardinal directions. The ultimate goal of this presentation is to just talk about both types of actuation, show how they're different, show how they're the same, and reinforce the idea that it is important to make an attempt to try to limit the amount of actuation necessary for your project to the essentials.
Brad, this reminds me, Brad, you're an editor, one of your great tasks here, right?
Yeah.
The rule of writing is omit needless words,
Yes.
omit needless axes.
Yeah,
There you go.
Yeah.
Why use 4 if you can use 2, right?
Okay.
You gotta remove all the stuff that you don't need for cost and also for long-term stability. Fewer parts means a stronger structure in general. So back to the slides here, we have a nice image here. This is actually an AI generated image of what GPT thinks a 6-axis robotic arm looks like versus a Cartesian robot arm within the context of a industrial punch press. And you can see here that it was able to arrive on the fact that one is cantilevered, supported at one end, and the other is supported on both ends, or simply supported.
Hey, Ben, if you have a cantilevered robot at 6-axis, and you're holding an object out, and I'm thinking about some of the applications done with very heavy parts. It has to exert energy the whole time on every axis to hold it in position, correct?
Sometimes there are ways for the axes to lock,
Lock,
break
okay.
down, break on the. But yeah, oftentimes the motors are set up with enough ratio of transmission, and so they're not back drivable. And so there's trade-offs to both, but generally, if you want to hold something in position with a lower cost robotic arm, it needs to be have the holding torque applied to it. That's not really a necessarily drawback of a robot arm specifically, but because, for example, a Cartesian robot, you could unpower the z-axis and it could fall down just as easily as you could a robot arm. So that's not necessarily one or the other. This is a nice little video here. This is another AI interpretation of what a 6-axis arm versus a 3-axis robot is. It interpreted this 3-axis robot as essentially a 3D printer, and the robotic arm as this rather just rather interesting flopping around arm here, where you see it kind of self-intersects in the video. But
What AI tool did you use to generate
this
that?
is GPT as well, Sora, an image generation, video generation tool.
Great.
You can build some apparatus in AI, and it shows you kind of a general idea of what it should look like, but not necessarily how to build it whatsoever. Okay, so move on to a little bit of math here. This is some, for those engineers out there, this is some beam bending. This is really quintessential engineering. Everyone draws in these equations. These are the beam bending equations for both cantilever and simply supported beam. I'm showing here the deflection for a cantilever and a simply supported beam. Of course, the cantilever in this case is the 6-axis arm supported on one end. If you notice, the image for the cantilever is not quite right because it was generated by AI. But imagine that's actually a cantilever. The simply supported beam is the Cartesian system. And it's supported on both sides, it's pinned on both sides. And so in these both cases, we're assuming a similar cross-sectional area, similar stiffness modeled by I and E respectively, and a similar force, tip load versus center load, denoted by P, L, and being the length of the beam. So identical loading, identical geometry, and you see a factor of 16 different fundamentally here with these two loading cases. And this can equate to a 16 times factor in cost. It doesn't usually, but it is a big number to think about. If you can buy a robotic arm for 16 times more than you would a Cartesian system, would you want to do that? Maybe. This is a quite verbose feature comparison table, touching on some of the fundamental principles we just covered. Some of the points here that if you look at precision, Cartesian robot, you can get much higher precision and repeatability than you can with a 6-axis robotic arm, and that is a function of its stiffness, as I just talked about, entirely just stiffness, but also relating to the stacked axes. As axes move up on the arm, the stiffness decreases, but the accumulated error also will increase linearly as you move up the arm. And so if one axis has a certain amount of error, that next axis will add to that error. You can build a Cartesian system, for example, a core XY system has two moving axes that are independent from each other, and so the error does not accumulate between the axes. And so you want to have independent axes that are all affixed together to make your 3D motion system, ideally. Of course, with higher speed, you can achieve faster movement with similar energy scaling. Obviously, energy scales with 1/2 mv squared, and so as you increase the velocity by a factor of 2, your kinetic energy increases by a factor of 8, and so that tells you a little bit about how strong the machine needs to be to move fast or slow.
Does this in effect mean that because of the rigidity, you could use a smaller Cartesian which weighs less, its self weight could be less? If you need the rigidity, you're going to have to use the larger, sometimes in some applications, you might need a larger 6-axis, which then means it's more mass to move.
Yeah, in general, yeah. Like for example, if you're trying to get a Cartesian system moving faster than 5 meters per second, for instance, it needs to be so strong to resist that motion, so structurally strong, it becomes heavier and heavier. You need larger and larger moments, and so it's kind of you get limiting returns on its motion. You need to do something more clever, like cable driven, or belt driven systems, rack and pinion systems, or even pure linear motors, which have a direct connection to a platen. I'm digressing here a little bit. So a Cartesian robot, in summary, is great for long distance pick and place, heavy part transferring, high precision milling. I don't think we see any 6-axis robotic arms with milling heads on them very often. We maybe see that in the aerospace industry for layups of carbon fiber, but not for high tooling force. 6-axis robotic arms, great for painting and welding. Painting is probably one of the biggest markets for it, and complex assembly tasks, which we'll touch on later today. When I was developing this presentation, I had a little thought here. There's actually a hybrid concept that could be possible. If you have two robotic arms that are kind of hand to hand, or like grabbing the same part, you can integrate both ideas where you have the stiffness of a simply supported beam, but the complexity of a 6-axis arm. If you can essentially double the price, you can get back that stiffness that you're sacrificing by having these cantilevered arms. So you build two cantilevers into a solid beam structure. This is sort of obvious for everyone's, but I'm just going to share it as a possible idea for system integration. So in summary, Cartesian, simple, stiff, precise, cost-effective, 6-axis, versatile, compact, and flexible orientation. But a hybrid structure is always a good idea, and you can choose based on the task need which type of motion system works best for you and your architecture.
I think the last part of that's a big part of this is understanding the differences. And that's where if you can get with a consultant that does automation or an automation house, they'll tend to pick from all the tools that are available. Right? It's it's whatever one you know tends to be the one you want to use next time. Right? Whichever path you go down, the right tool is the right tool. Not the one that's close at hand. I'm not using this, so I'm going to use this. My pressure run makes a decent hammer. Well, not really. Right? It'll do it, but
Thanks, Ben.
Yeah.
For that. Have you tried to model that hybrid system, or it's just an idea in your head?
It's just something I don't remember. I think we'll see one later in today, actually.
Yeah. Okay.
Potentially, but the idea of making a Cartesian system, making a 6-axis system simply supported, so it's constrained at both ends. You'll see this sometimes in cable suspended robots, like for example, the Skycam in stadiums. It roams in this huge volume, and it's suspended by cables on all sides of the stadium. And so that's technically simply supported. It's not a very good metaphor because it's cables and not beams and trusses and structures, but it's not cantilevered out into the stadium.
hang.
Right? Not
Suspended in all directions, right?
Yeah, and so like the advantages of having things supported at multiple ends is this factor of 16 stiffness, which is something that is like really important to understand. That type of derivation from first principles is foundational to the work that I do for TCR, is to like just really understand fundamentally is what we need to build for this apparatus from first principles, and then we can extract the necessary architecture and mechanisms to enable it.
It's an important aspect for us is finding the most efficient way to get the job done, which is meeting all the requirements, all the movements, but also you also factor the cost point, longevity, and everything else, cost of ownership, cost of purchase. So again, if we can omit an axis to do it.
Yeah. So I know you're going to show some slides with some case studies in a minute, but I'm curious if you could describe, without naming the customer, if you're going to, a case where they needed an automation solution engineered, and there was some question as to do we do this in a Cartesian system or with 6-axis robots, and how that conversation played out, or how the
I just
project
think the
played
one we
out.
did was an unusual one. It was feeding polycarbonate sheets.
Oh yeah,
Right, which were down to 4 thousandths or 8 thousandths thick.
2,000.
Polycarbonate, 2 thousandths thick.
Yeah,
And so it's like a sheet of paper, right?
Yeah.
It's, you
it's
can,
like it's tissue paper.
Yeah. but fortunately, not permeable to gas, which means you could use vacuum to pick it up.
Okay.
And the operating speeds we were trying to achieve were pretty substantial. So you can't just grab this part and put it in,
Yeah.
right? It it's a piece of paper, right? So you had to hold it in multiple locations. And, to get this thing in and out and, pull them from the sheet, stack them at the rate of speed we needed to do, it just wasn't really conceivable with a 6-axis solution. It just wouldn't be fast enough. Because the self-weight essentially of the robot itself was a barrier.
Okay.
Using Cartesian, the structure holds it in the moving actuator. I can't remember the speeds you could hit on. It was pretty
We
substantial.
did around 3 meters per second, feeding in and out of the press. We only had to use one moving head to feed in a sheet to punch it and to grab it out, move it out, put a new one in. We were thinking we had to use 2 different end effectors
keep
to
up.
kind of move one in as we're moving it out, but we got the speed high enough that we just had one robot. So it moves in and moves out very quickly, grabbing the sheets.
Right, so it was surprisingly price effective. Now, it's not flexible. Right, this isn't gonna be redeployed to do a completely different, like if it was a 6-axis or a cobot or whatever. Okay, I can make it do a completely different task and another completely different. This thing was form, function, designed to do this job. Right?
Yeah.
But that's what they needed, that this press was gonna be occupied with this task for a long period of time. And so we maximized the throughput and would keep the investment very low, and it was still very robust. With, the number of cycles you calculate could run, it was extraordinary.
Yeah, it can operate like 30 years and continue.
Yeah, it was very, and it was again, these were able to, okay, I need this Cartesian section. It was like, reach out, what's on the market? I need one of these and one of those, done. And, it was shocking.
So that's obviously part of the conversation too, then is do you imagine this system needing to be, or is there an advantage to something that's
In this,
reconfigurable,
Right.
or are we comfortable with?
yeah, and the thing
dedicated
is,
assets?
if I'm gonna run this for 6 months and or especially if I can pick it up and move it, well, that's redeployable, that's wonderful. If it's gonna sit at this press and do this job 20 hours a day for the next 6 years, the next 10 years, well, okay, it's redeployable 10 years from now, but it's 10-year-old technology 10 years from now, and it paid for itself year one. I mean, really, relax, So, I mean, its flexibility is a factor, but it's a factor, and it's not always now sometimes it's an incredibly important factor.
Yeah.
I'm gonna put it on 5 different machines. Sometimes it's gonna live in this spot and do its thing, and we're gonna retire it when you're done. So all those things come together. It was interesting, just to run a technology grant here, but the end effector for the testing, then 3D printed almost the entire end effector. Well, I mean, purchased vacuum cups and airlines, but I mean, the whole end effector was 3D printed. We got all done, and the self weight was very good and was plenty rigid. Like, well, what are we gonna make it of when we're done? I thought, he said, you're looking at it. That's it. We're gonna use that. Why would I do it? It's already completed. And I'd never even thought about this, right? There's just a few metal components, and it was almost all 3D printed.
That's pretty cool.
Which was wild. And, kind of nice if you crash it. Less shrapnel. And then today, we were at a manufacturer in the Cleveland area, and that uses a fair number of transfers. They're using 3D printed end effectors.
Are they?
If they crush it, it's printed on them. I mean, clearly, please don't crush it, but it was, another new technology that's starting to surface in automation. Do you see more 3D
yeah.
printed componentry? Not metal, I mean, 3D plastic polymers.
End of our.
Oh, for sure, for making tooling, you see it a lot.
It's pretty remarkable. So anyway, that's just it's a work thing, so. Oh, the slide.
Time for your
it.
slideshow?
Yeah, I just have to add to that while Todd's getting set up. I think what he was saying, and I have to reiterate, is like each technology we're talking about today is not, we're not trying to say like everything should be a Cartesian robot or everything should be a collaborative robot or everything should be a traditional robot. I think each has its place in the right situation. And so making sure that you're working with someone who knows what you're trying to do and
Sure.
someone who understands different technologies, helps you select the right technology is really important. And I think that's really a key takeaway for anyone who's watching right now is each automation and each type of technology has its place and its value. And so
Something
picking the
that,
right one.
just a quick caveat to that, something you want to make sure that you're understanding is that when you look at a robot arm moving around, it looks very cool and futuristic. And that shouldn't be a design decision. It might be, for some people, it's kind of like hard to dissociate from that, but just because something looks cool doesn't mean it's necessarily more effective at what it does.
Right.
Yeah, it's something I've said many times for my clients. It's like I'm not in love with this technology or that one. I'm in love with whichever one has the best ROI for you.
Yes.
Whichever one is the best tool is the best tool. Sometimes it's a hammer, sometimes it's more involved, right? It just depends. So it's very situational. And it's always when we walk, it's real important is, when you walk into an application for a client is to walk in first with a list of questions. There's a lot of questions to be asked to understand all the factors that go into it to make the best decision. You can't walk in with an answer. If you walk in with an answer in your pocket, there's a problem. You've made all these assumptions and decisions before you've seen the situation. It doesn't work out very well.
No, as long as it looks cool.
Yes. Well, my partner's designing as long as it's heavy. So I'm gonna, this is, this is a new automation, technology that's becoming available, right now. This is fairly cutting edge. I'm just not to the minute, but, sorry, get back out of the way here. I lost my presentation. Why did it do that? Let's try this again. So I'm going to highlight today for our audience this company called Isochronic, which I would not be well known yet. This is a fairly young company in Switzerland. And so Isochronic is, like I said, located in the beautiful country of Switzerland, and their work so far has been in Europe. But they're doing some pretty remarkable things for our watchers, our viewers who also run lasers. So they started working on some automation for lasers specifically. In the course of the last several years, you're going to see a wide number of arrays, these guys, of awards they've won in Europe, design awards, innovation awards. There's quite a pretty significant list of technology awards they had. And earlier this year, this fancy slide is an iPhone photo I took of a projector screen, so that's why it looks so high class. But I was in Boston for an automation show, and they had the 50 top innovative awards. And they won one of those, that award for innovation. So the challenge that they identified, like every issue you're doing, if you're trying to find a need your client has, we all live by helping our clients. Whatever they need, that's what you're trying to help them do. They've identified, well, lasers are getting faster, incredibly fast. In fact, when you watch lasers cut now, the fiber optic lasers, the fastest ones, it almost looks like it's a sped up video. It is shocking how quick they can move. But the automation to pick the parts from the cut lasers hasn't gotten any faster. There hasn't been any innovation there yet, and this is what they put their eyes on. And of course, there's a lot of people still manually destacking. Sure. So I mentioned earlier, we have a company that a safety officer for one of our company clients that has a number of around the world, around the United States. She could tell me by the number of people hours of work about how many cuts they were going to have, about how many reportable injuries, about how many soft tissue for manually picking parts. Anyway, there's the problem. How are we going to get these parts off this thing and get this, take use of that speed? So there is some existing automation using a Cartesian style system with a single pick head. They've been out there for a while now. Cartesian in this case, because it's a very large span, right? So Cartesian makes sense because you're over a very large sheet over a large area, and you had to also get off the sheet itself, get to where you stack the parts. So this would be an enormous 6-axis industrial robot. It would be very impressive. So this is a good application. But what they did is they said, listen, we want, instead of having one head on the beam, we're going to put two heads on the beam. And hey, while we're at it, why don't we put two beams together? And then that wasn't crazy enough. They said, hey, if you noticed here, this is not broken. Right, you see a standard Cartesian, everything's at 90-degree movement. This is traditional Cartesian movement. And so they said, wouldn't it be interesting if we could angle the beams? So we can certainly reproduce this movement, but I'm going to add one more. So I'm going to show some videos of this, but this was this concept. Now, the amount of, I don't know how much caffeine it took to write the software. So these four robots rushing back and forth, skewing left and right, didn't collide with themselves, including keeping track of the part that they're carrying, its shape, because it's larger than the pick head, and the elevation it's at. I mean, this is some mind-bending stuff here. So in this case, they're loading sheet with it, which you can do. They're just got a spot they can actually dump the skeletons, and it's picking parts here and stacking them on these pallets. So here's an actual photograph of the first installation, which was just a little over a year ago. So this, this is new in Europe and has not come here yet, but I think we're feeling it's gonna get very popular. So there's the actual application. Here's another system that was being put together. This is during assembly, also in Germany. So I'm gonna run a little video here. We'll just kind of stop it perhaps in a few places. Here we go. So you're gonna rotate that the pick head has rotational capabilities. If you notice the parts during the nest, they're oriented in different ways to nest the part more efficiently. So it has to be able to pick the part up and rotate it to where it needs to be for the stack. Now we've talked about the acceleration of the self weight, right? If you had to move the entire crossbeam back and forth these distances, that's a very large mass to move, and you can do it. It limits your speed, but if you can skew one angle out, that's quicker, and then that smaller pick head can go considerably faster back and forth across that area.
Yeah, they must have some data that explains how much more efficient it is than the conventional system.
Versus hand stacking, it's something like it's over 200% faster than hand stacking. But even they did a model against a traditional 3-axis Cartesian system, and even giving it multiple pick heads, they were like double the speed.
Double the speed.
Yeah. 100% or 90. It was 9. Okay, I think it was 96% faster. Almost. So, but I mean, it's considerably quicker. And in this case, this client is running small parts, but here's an example where they combine multiple pick heads to pick up larger parts. So this starts getting back to operator safety. How would you pick that part manually? What if that was 1/2 inch thick or 1 inch thick? What if it was a burn table on a plasma and it was 3 inches thick? Right, so they can upscale. The biggest secret here for these guys really is their kinematics, software and kinematics. They can put bigger and bigger pick heads and pick more weight up. So it's really an innovative solution that's addressing a real issue. With just, how do we get faster? How do we take advantage of the fact my laser can run faster? That bottleneck.
Very cool.
I don't think I need to spend more time on that, but I just wanted to introduce that. I think you're going to see more of this company, is my guess. But it's interesting to see this technology coming from Europe, and it looks like it's, people are already expressing interest here, because especially in the upper Midwest, right, we have a lot of demographic, there aren't as many people working.
Sure.
So how do we keep these stations manned? We do that. So very interesting.
Right, and alleviate the bottlenecks that these super fast machines are creating.
Yeah.
Right.
Yep.
End of line part handling is a big deal everywhere.
No doubt. There's another use case I wanted to bring up here today, which was this is a contract manufacturer. I'm going to use this model because it's actually easier to see the model than actual photographs. It's hard to photograph something this big. So they have a 1,000-ton press that was coil fed, and they could use some progressive dies in it. They did some progressive that were finished with hand transfer. The volumes kept going up and up, and then they got a new contract where this part needed a 5th hit. There wasn't room in the bolster for it, and they needed some more tonnage. So the 1,000-ton press wasn't long enough, didn't have enough force. And also the volumes were higher, so it was becoming very challenging to try hand transfer. It would have been very, very difficult to do. And the volumes are high enough that it was nice to take advantage of the material savings you get if you can transfer it to the coil feed. So all those things came together. So what we did for them, if we took their 1,000-ton press, which is just remained where it was, we added a 250-ton press from their building. This is a redeployed asset. They had another machine that wasn't underutilized.
You're able to name that.
Yeah, I'm sorry, I shouldn't. In fact, I want to credit them. PMI is in Bloomington, Wisconsin. Thank you. I'm so used to not saying the customer's name. It's hard for me to remember when I get to, but yeah, PMI is a contract manufacturer in northern Wisconsin. They do all kinds of processes, stamping and fab and cutting blanks and machining. And they're a very interesting company with, by the way, it should be an article. They have a remarkably good educational setup to reaching out to the high schools and local tech colleges. And they're basically, well, we're going to have to create our own tech department. It's very interesting what they're doing there. So they were early adopters of automation. They had early weld robots and things like that, 6-axis of course in that application. And so what we did here is this, so we'll go back to Ben's thing, is a gigantic Cartesian automation cell, right? This machine body runs left and right. It's got a vertical axis here. And we've added, in this case, a cantilevered outflow here. We can actually reach out into the tool and come back, right? So we're adding even though it's Cartesian, there's a cantilever load here. And in this case, there is a fourth axis, size left, right, up and down, in and out. You'll see in the video that it rotates. So it brings the part out, carries it over to the station here, rotates it 90 degrees. So the next speed feeder can grab it and load this next press. So just a few more things I'm going to show you from this angle here from above. Not shown in this picture, there's two more presses next to it. These conveyors over here, sometimes the part just comes out and it's done. But if they need more hits, they can pass this to the press next to it is either 400 or 500 ton press, and it's got room for 2 more hits. There's another press after that. They can all be connected. You can automate from 1 press to a 2 press tandem line to a 3 press to a 4 press. And 3 of the machines were already in place. We didn't move. So again, it's if this was a greenfield site with a super high volume and a known thing, we would line these presses up in the tandem line. We'd run faster. You know? But this allowed them, for just the investment in the automation, to automate this entire cell. I'm gonna spin around. Here's some other fun things we did here. The scrap comes out. We run it out of the building to a much larger scrap tub, so the automation doesn't stop. So they have to move scrap. You know, the normal things you do to try and improve.
Remember how long it took you from quote to completion or some type of time frame?
Oh, there was probably 6 months of discussion, maybe. Well, you know, interrupted. Like there was 3 or 4 months of discussion. Then it was okay. I don't need it yet. And then it was like, I gotta have this figured out right away, and we jump on it and get it done. And then maybe 9 months to execute or something like that. Maybe a little more to execute.
By adding this automation, did it stop them from being able to run other dies?
Oh,
in those
thank you.
presses?
That's an excellent question. No, it did not. This 1,000-ton machine has got guarding up closer than it uses when it's running coil fed or hand fed, because it can coil feed and run prog dies, or they can do hand fed work in it. The automation, they just slide down to one end and park it up in the air. And so it enables, this machine was designed and configured so we could continue running another operation. Because this particular job didn't fill this machine up. So they wanted access to it. So we left it able to do both. So I think I was thinking about
And
it.
if they wanted to do something similar with a different part, they would just have to change the tooling on the end.
Yeah, just the end effectors. Let me see if I can get I'm gonna try a couple of photos first. And then so here's a picture of the actual machine with the equipment installed. Let me blow that up a little bit. So obviously it's hard, we're behind the guarding, so you don't get so close to the automation. So inside the tooling, this first station is coil fed. It's been separated, picked up, and runs through these additional tooling. We'll watch the automation, but it'll come in, it'll pick up all the parts simultaneously, slide over, so the last part is actually in the window. Sets all the parts down, side shifts, backs out, it runs down to that other station we talked about, and then sets it down to be picked up by the next piece of automation. It's under photo here. So here's more of an angle view, so you can see the other machine next to it. So you can see these are not shiny new presses, right? These are machines they've had for a long time. And they're in a completely automated cell. We did some upgrades to the machine controls on the press to accept the automation, right? Because the original controls weren't designed for that. But they saved a tremendous amount of investment by using some existing presses.
Sure.
Right? Worked wonderfully.
And then plus the fact you said it's flexible. I mean, they could run other
Rather
tooling
work.
in their other jobs. That's
Exactly.
certainly a consideration in the
Yeah.
type and level of automation, you know, how specific do you want to make that line? Or
Right.
how flexible do you want to be in that all of,
It's
that all
a
informed.
really good observation, though. It really is, because it's a design. In this case, flexibility was more important than ultimate speed. If I was trying to do it faster, it'd be different presses lined up a different way, and this was set up for somebody running 24/7 in a high volume of the same part or similar part for a long period of time. We would do this differently. In this case, flexibility was a major factor for the client. So it was important. So I'm gonna try and run a video here. I'll have to take me on faith. It's smoother in the real world than what you're going to see. You see the rotating station down here? That part's gonna turn 90. Another feeder that looks like this one's coming from the other press to pick it up, take it to the next machine. This is actually during one of the very initial die trials. As a matter of fact, this is actually right out, like early in the process. We're still testing things out this day.
When was this project completed?
Well, a couple of months ago.
Oh, really?
Yeah, we were actually done and waiting for the tooling in this case. One time in my life. Usually people breathe the fire down my neck, but it's really interesting how it worked out. And we maintained flexibility when they needed it. A lot of challenges here. I mean, some of the challenges aren't as obvious. The motion is the motion, but doing the guarding properly and putting guarding zones in place, this is really important in automation so that there's no unintended actuation while somebody's inside this area. A lot of careful thought, barriers with locked gates. So and scanners involved. There's a lot of detail work that has to happen here that's not as obvious, right? In this kind of application, and the system can be made faster by putting another feeder on the other side. Like I could take the one out and go away with it and then move the other ones over and come over. I see that extra motion you're seeing there, right? It's going into the window and coming back out.
Right.
Well, it was fast enough. It was still faster than they needed. So there was no reason. But if we were trying to go faster, we would take another one of those devices, put it on the other side of the press. So I can do simultaneous movement. I can come in and get the part, take it away and take it to press 2 while the other one comes in, slides everything over, and then the feed fits. Right? And then our throughput would be higher yet. And the spans that are, Bennett talked about characteristics of the Cartesian. These are fairly heavy parts. I think they're certainly more than 50 pounds. I don't know if they're over 100 in this case, but they're also fairly far apart. This is a long travel. It's 20, across the whole thing here, it's 25 feet or something. So we're moving a long distance, a heavy weight, very fast over a long distance. And the way that system is built, that beam on top there, the press next to it could have been 20 feet further away. Just run down the run. Yep. So it's an excellent application in this case for a Cartesian style because of these heavy load, long distances. So thanks to PMI for willing to share. Thanks them for ordering it. Appreciate that very much. But thanks, they were very kind to share this, right? And show us what they're doing there. And I think some contract guys think that, well, I'm not GM, so I can't automate like that. It's like, well, you can automate the machines you have. In fact, it's one of the ways to better utilize some of these older stamping presses that are slower, right? All the progressive die lines we do now, they're servos. They go very fast. And it's really hard to compete with a progressive die servo press with your old 600-ton press and a 14-inch stroke, and it goes 30. But you can automate that machine because you can't run that the servo. You don't run faster to a servo. It's fine. I mean, all of a sudden, if you become as a candidate, like I'm going to redeploy that old asset and I'm going to automate that, be it with 6-axis or Cartesian, doesn't matter. Now this thing becomes an automated cell. Its slow speed doesn't matter because we're waiting for the automation to move the parts and things anyway. Right. And all of a sudden there's no penalty. So it's a great example of redeploying that type of asset and keeping it valuable to the organization. Oh, good.
Thank you. So we talked a lot about conventional or traditional types of automation, but tell us what you're seeing in the use of cobots in MetalForming and fabricating operations.
Yeah, absolutely. So, I mean, like I mentioned earlier, really ultimately each technology has its applications, right? And so I love the idea of using old equipment and not, throwing it away. I like the idea of using your aging workforce and then all the knowledge they have and keeping them as part of your organization. That's really powerful. So all those messages also continue over into collaborative robots. And so as we get the presentation pulled up, what I want to share today is a few things. I want to share about collaborative robots, of course, because I'm from Universal Robots, but I want to share also about something called physical AI, and we'll dive into that in a little bit. But before you tune out in the audience, I think I've got an interesting message and a little bit of a warning for you that I think will have value. So not going to spend a lot of time here, but I mean, doubling down on what Todd's already said, safety first initiatives are motivating folks to make investments. The aging workforce, rising labor costs, all these things are coming together to really force us to automate. I mean, even though the market's a little bit strange in manufacturing right now, there's still, I looked, the July number for the Bureau of Labor and Statistics for the United States, it's May data, is there's still 414,000 unfilled jobs in manufacturing. And there's still 7.8 million unfilled jobs in the United States. So we're still battling for workforce. Even if maybe you filled a few more jobs than usual in the last year, you probably still have some openings if there's 414,000 unfilled jobs in manufacturing. And so those persistent vacancies really cause challenges. Those are operations you don't run or presses that sit idle and those kinds of things.
We run networks where people report reasons for downtime, so they can try and solve them, right?
Yep.
And one of the codes I always have them to ask for an operator input is no operator available, which is to be used when the press is ready, we have a die, we have material, and we would like parts. There's no one here to run it. So first shift clocks out, the press is down because of there's no operator to run it. Sometimes on second shift, they're short, and no one can, they have 5 people and 7 presses to sit. To your point, right? This happens. And we're measuring it, and our clients are noticing how often they're running because there's no one available to do the work.
Yeah, that's good advice right now in your work log. What is downtime? No operator available. If you don't have that in the log, that should be there.
Yeah.
That's good advice.
It's scheduled down. Well, if it's scheduled down because there's no one to run, it's the only reason it's down. That's a different
That's
thing,
a
right?
different problem. Yes, absolutely. So I've got to put a generative AI. You can't get away with not talking about ChatGPT or Google Gemini or one of these things, right? I mean, you can't get away without talking about it. But I'm going to bring it up for a very specific reason. And what I'm going to bring up is image generation. So this is a picture. I didn't make it, but I got it from a Substack, and someone went out and went every couple of months and gave it the same prompt, make me a image of Harry Potter. And from February 22 to December 23, so about 18 months, look at how much progress was made in the ability of generative AI to make an image. And while we were talking about this at lunch, Ben, who is a little bit of an AI aficionado already, he actually went and made a prompt today just at lunch of like, what was your prompt, Ben?
Harry Potter using an industrial punch press,
Harry Potter using an industrial punch press. How long did it take to generate?
20 seconds.
20 seconds.
It's amazing.
Okay, and so, I mean, it's a little bit of a gimmick, but the reason I bring it up is think about all the power and all the knowledge we have now in creating photorealistic images. And think about how that power can now be used for processing images of the real world and what exists in the real world. And so the reason I bring this up is we're going to talk a little bit about machine vision and AI and how it applies in manufacturing. And I want you to remember this Harry Potter slide, that in 20 seconds, we had Harry Potter at a punch press. Crazy.
Yep.
If I had told you in 22 that would happen, I would have told you it was nuts. Right? I mean, really. Some other things and trends that I want to bring up is, when we look at injuries, we talk a lot about safety. Safety is a #1 initiative in most corporations and most organizations. One of the most dangerous things going on in your plant is fork trucks as they move through the plant. 40,513 injuries from the material handling equipment Distributors Association over a course of 2 years, 21 and 22. It's a lot of injuries. That's hundreds a day. And so this is a challenge, whether it's days away from work, transfers, fatalities, or job restrictions. It's causing negative implications in the plant. And so we can't ignore that.
Driving the use of AGVs.
Driving
Seeing more and more AGVs. Doesn't require an operator, and it drives patiently around the building.
It's if someone goes near it, it stops, right?
I was at the airport the other day, and a wheelchair drove by me by itself. It was being deployed, and I hear this sound, and it's like a pleasant sound.
Like a song.
Like a song. Like, I look down, I'm like, what is going on? And this wheelchair goes, and I'm like, and then a little while, 2 more. they're being deployed to whatever gates they need wheelchairs at, and it goes and drives itself there.
That is,
The first time I've ever seen an AGV in
Incredible.
an airport,
yeah.
right?
My first interaction with an AGV was ordering food to a hotel room that I didn't want to go downstairs to go get. So. Yes, absolutely. And then I looked into for a long time about robotics injuries, but there's really not that much there. There's some headlines, but not really much research behind it. And one research study from the NIH that came out, it showed only 77 incidents in 7 years, so 9.6 injuries a year. So when we look at safety, automation is a very powerful way to reduce injuries in the plant and to reduce, to make it safer to work in the plant. And so we bring automation and robots in. This is an opportunity to bring safety to our production sites. And so when we look at what we're automating, it comes down to those things that are unsafe, those hazardous tasks like holding, like you mentioned, people getting cut by handling metal parts, whether it's a physically straining task, like trying to move a 200-pound part or something like that. And then the dull, repetitive tasks, you know, repetitive strain injuries and repetitive stress injuries, all these things can injure folks. And generally, people don't want to do things that are those things.
Arduous, yeah. I would have to think that, you know, always one of the challenges for welding is getting the fumes away from the operator, because that's very dangerous. And so they're doing doing great things with ventilation, but your robot doesn't breathe.
Nope.
Probably
Yeah,
similar process. We'll just keep them away from the smoke altogether.
I mean, if you've been following Will on welding's one of my passions. I don't have a lot of welding in here,
Yeah.
but when it comes to welding automation, that's a great point. That it's helping remove really unergonomic tasks from the welders, but still utilizing their knowledge, their expertise. How should the weld be built, and is it going to pass and be certifiable? And all those pieces are really important part of the process.
They make the welder the program.
The welder's there, yeah. The robot's doing the welder's welding task, because either it's hard to make 1,000. I have a partner, he says, a customer that says, I can see exactly in the 1,000-piece run where the welder got bored.
Sure.
Because the quality changes as the welder gets bored.
I had a client ask me once, this is a stamping example, but it's still the same point. If you have a part with a knockout, the top, the piece goes up with the die, the knockout knocks it out. Cleverly named, right? Well, sometimes the knockout doesn't, part stays in the die. And so occasionally an operator will put another blank in to make another hit. And it goes up and they put another blank in. And my record is 17.
What?
They were pulled seven. Now, to be fair, it was aluminum. But this operator had packed 17 parts in the die that just disappeared. They weren't coming out.
Oh my God.
Like, why? And my guy said, how could she be that dumb? I said, no. Problem is not that she's dumb. Problem is she's not dumb.
Yep.
And she's bored. Your mind wanders. The robots are dumb. They don't get bored. Over and over, exact. Right. So, you know, put her on a task where she needs to be more creative. Check the parts for quality. Her problem is not that she's dumb. Her problem is her mind wandering, and you couldn't do that job without your mind wandering either.
Right.
Don't point any fingers.
Yeah, I think that's a real trick. Let's redeploy people where they're adding value to the organization and utilize them, because we only have a certain number of people. There are 414,000 unfilled positions in manufacturing. So the people you have, how do we deploy them to create the most value? And standing and putting a part in the press, not necessarily creating value. And so when we're looking at what automating, whether we're trying to make more parts, these are more the traditional things, right? Improving quality or adding capability to our production. But ultimately, we're trying to win more business. So why are folks adding collaborative automation? To your point about AGVs, Todd, I've got to put this slide in here because to me, in a metal shop, this is an opportunity for us to really, there's a lot of material movement between presses. Conveyors maybe don't make sense because of the way that we're set up. We're driving fork trucks around just looking for work to do, and we're creating risk inside our plant for safety risks. And so AGVs and AMRs are tools that are safer in the plant, and they're able to automate these kinds of material movement applications, whether it's bringing raw material or blanks to an operation, or taking parts to the outbound, you know, to be sent out to the customer, or taking scrap bins over to the scrap area. There's lots of things that the AMR can do that make it safer to move material around in the plant. But generally, when we talk about collaborative robots, folks, you know, typically picture something like this, right? They picture a 6-axis robot. You've talked about a lot of the benefits of the 6-axis robot already. What a collaborative robot stacks on top of that is really what's called a force sensor. And so it's looking for anytime it makes contact, it gets a force it doesn't expect, it's going to stop
Too much.
yeah. And what that does is that creates safety for people working around that automation generally. And it also creates safety for the equipment. So your likelihood of damaging maybe a guarding that's around it or another piece of tooling around it is lower, because as soon as it maybe makes a collision by an accidental program or something, you're not damaging the robot or the tooling. The other thing about collaborative is, if Ben and I really enjoy working together, we like to collaborate, right? And so making it easy to collaborate with Ben is really a trick. And so collaborative robots, regardless of the brand, are typically easier to program and to work with for an operator. So a lot of times an operator can use a collaborative robot versus maybe a piece of traditional automation. And so
Redeployable without bringing engineering down to do a more,
definitely.
or a little higher end or more complicated. No, don't talk about a laptop and a cable to a drive.
Yeah,
Right.
yeah, maybe your setup folks could change over from one program to the other very easily. And that means you don't have to have an engineer down or something like that. That brings value to the organization. So there are lots of applications in metal fabrication. Really, you name it, collaborative robots are doing it in metals. That's my business and I know it very well. But I will just point out one of the top industries for collaborative robots and all the market studies is metals and in metal fabrication, from HVAC equipment to shipbuilding to yellow goods to machinery and construction and industrial products and more. So they're being used in all those markets. And it all comes down to that kind of ease of use and then that kind of safety force feedback functionality that's built into many of the collaborative robots that are out there. And the flexible redeployment is really the key. And I like to point out also that a cobot is a robot. And so I talk about safety, but I have to be very serious that you should always do a safety risk assessment when you bring automation in, whatever it is, right? Because this is making decisions without a human there. And so you want to make sure that you're assessing for all the risks. A collaborative robot brings features that allow you to mitigate risks during your risk assessment, but you still must do a risk assessment and understand if it requires safety around it or not, based on the whole application, not just because it's a robot. To your point about just because it looks cool,
Yeah, that's.
you can't just make a decision because it looks cool. You have to assess the whole application.
You add like racing stripes to your Cartesian robot.
Makes it look cool.
Well, and like, the other thing we look at with guarding, whether we're using 6-axis or 2-axis for large part handling, the robot can stop, and that's wonderful, but if it's carrying a 50-pound part and it's moving and it loses control of the part, well, now it's a projectile. Right, so you have to, when we get into material handling in the stamping area, especially when they're bigger parts, well, the part itself becomes part of your risk analysis. Now, if you're picking up parts the size of a deck of cards, hey, the part's not a hazard there. You can drop it, it's fine. So that's why you can't. I really appreciate your there should be a risk analysis on this application of what we're doing.
That includes the part.
Whether it's
What am I doing? What are my hazards?
Yep.
Like I want to have my 12-year-old work on this, and I like this one. It's the one I like, right? So okay, I'm kidding. I like either of them. Kidding. No, but my point is, you should look at it. Where are my hazards? Where am I likely? What kind of injuries are they going to sustain here? And it's case by case. You have to really analyze it.
Yep.
People are always like, well, what do you do for safety? I'm like, I don't know. I got a lot more questions. Let's go through it. Anyway.
Yeah, no, it's a great point, and all really require that as part of the process. And so I get asked the question a lot: cobot versus robot. Why should I choose a cobot? And I would say generally it's a little bit blurry about when is the right moment or not, but each kind of has their place. I'd say classically a collaborative robot kind of deploys in a simpler automated cell, although I've worked with many folks doing it in more complex automation applications, where traditional industrial robots are typically more complex with lots of other automation tools. Like you have that spinning repositioning device in there and an additional robot coming into the application. So
And again, if it's a cell where it's passing parts through a machine center and then a this and then a that, and it's doing the same part over and over and over.
Yep.
Well, that all factors into it. Every one of these things. It's guarded anyway, so it changes it.
Yeah, and I would say if you need to be able to redeploy the application, or you need to be able to use the automation on two different presses, right? Or you need to be able to, I always like to mention the ability to push it away. So, when people buy a piece of capital equipment like a stamping press or a press brake, sometimes, I mean, your application was a little bit different, but sometimes if you add automation to a press brake, that piece of capital equipment is now an automated press brake. And you cannot go and use that manually typically. With the collaborative robot, often we can push the cart out of the way and then we can run a manual process on it. So if you have to be able to be flexible with your piece of capital equipment, then collaborative automation often becomes the choice to be able to do that. Not that traditional robots can't do that in certain situations, but often they can. So, and then my last point is what we see is the collaborative robot implementations typically have a lower total project cost than a traditional automation application, often much less than $500,000 for the full automation investment, and typically shorter project timelines, weeks or months versus months or quarters. So, each is kind of has its place depending on what you're trying to do. And I guess I should have added Cartesian robots to this chart too, but they all kind of have their own kind of comparisons.
I have a quick
Yeah.
comment you just sparked in my head right now. As far as redeploying, well, you can redeploy an industrial robot, sure. But as an integrator, the guarding around these things, if the robot itself doesn't have this capability to detect and stop, you're guarding the robot. So it's not easy. It's redeploying the guarding. If you have physical fence guarding with interlocks and wiring, this is not something you just move out of the way, right? You can set a robot down on some location pins and lock it down pretty easily and pick it up and drive away. That's reasonable. But if you have 38 feet of fencing with 2 gates in it and some lights, move that out of the way, right? So that is definitely a factor, right? Where it makes it much easier to redeploy rapidly. Because it might not have this very cumbersome guarding apparatus around it.
What's the difference in the payload and the reach of cobots and robots? And are cobots are they evolving to longer reach and heavier payloads or not such?
Yeah, I would say, as soon as your parts get heavy, you're in an industrial robot.
Okay.
10 pounds.
Collaborative robot, the largest one that Universal Robots offers is 30 kilograms. There are some that are higher than that. So
That's pretty heavy.
Yep.
Okay,
So,
But if you have a 200-pound part, different world.
yeah.
Right?
for now.
Yep, for now. So, no, yeah, but it's a great question. So all those factors of the application come together. The scope of work of the project and writing a good scope of work is really important to be able to identify the right technology, whether it's a Cartesian or a 6-axis or a collaborative robot.
What's the reach on a 30-kilogram payload?
Like 1.3 meters. So it's, it's a European company, so I have it all in my brain that way. So
Yeah,
yeah,
I
I think 4.5,
Okay.
give or take. Someone's gonna judge my engineering math there. I'm waiting for Ben to give it to me to 3 decimal points. No,
58 inches
good.
more or less.
Yes, yeah, there you go. Okay, 58 inches. So great. So not last, but I've got a couple of case studies. Here's an example out of Poland, less than 25 employees. They're making furniture and lighting. They had to really boost their productivity to support a customer. And they're just doing a simple single hit. They've got a disc blank that they're putting in for a light fixture that they're making. And so it's a simple application. And really the trick for them was to be able to deploy it and redeploy it as they needed for the different parts and products that they were making. This is a previously on Manufacturing Live. I put this plug in here for you, Brad and Lou. But this is the folks at Pennant Molding. Go and watch that. I highly encourage everyone to go back and watch the recording from April. They shared all about their automation journey and what they're doing. But this was Brad, remind me, it's a appliance part?
It's appliance parts, right, that are roll formed, right? So I don't know, they've got, I forget, 10 or 12
Yeah.
robots on end of line.
They're
doing,
just
doing packaging it. Well, they're doing inspection, inline inspection, and then using cobots to package the parts.
to pack it in the bin.
Yep.
Okay. Yeah, really, it's a great application, and I really enjoyed that MetalForm Live. So go watch the recording.
You just reminded me of a video
Yeah.
I was gonna play, but where starts off in a stamping tandem line with Cartesian, ends up with multiple 6-axis to stack the parts.
Oh, yeah.
Because we had to flip and flop and turn to stack them neatly to get a nice dense packing, right? So, because the part's been all formed up.
Yeah.
So there's a case where blending, which one makes the most sense for which activity.
Oh, yeah,
We were talking about the pack, inline stacking. Oh, yeah, that's right.
Mhm. And then press brake tending is a very common application for us. It's probably the most common forming application that we have right now. And you have to have a little bit of volume because the time to teach the part takes a little bit. Each part's a little bit different. When do you grip it? When do you let go? All those kinds of things. But we have a lot of folks doing press brake tending right now because of its flexibility. It combines the flexibility of the collaborative robot with the flexibility of changing out the dies and parts. So all of it with the press brake. So really a powerful tool. And then this one, when I heard you talk about two robots working together, I smiled because this is an example out of Japan where they had two people putting parts into a press brake every day. And over time, it was really a challenging application for them to do. When they get tired, they don't get the part in the right place or something was in the wrong spot. And I think when you have an application with this is a big, long part, so it's not possible for one person to handle. Any place where you have someone doing something 1,000 times a day, that's a big red flag to automate.
Yeah, I would say so.
Yeah, the very definition of it, right?
And then here's an example of end of line. To your point, there's a lot of folks who was coil fed, but then at the end, taking the deep drewed part,
Yeah.
deep drawn part, deep
yeah.
drawn part. Oh man, wow!
We drew it yesterday.
I drew it.
Yesterday we drew it.
I love it. Yes. Oh yes, definitely. It's not like it's live. But that's good. I love it. Deep drewed. Okay, but wow, that broke my rhythm. But you get the idea of palletizing those parts and sending them off to the next.
I get a lot of these spark thoughts, right? I was thinking about one of the advantages of if you can pick the parts with automation at the end, you can orient the parts very carefully. And you're thinking about your automated robot, your press brake, right? Well, the first thing you have to do is has to acquire the parts in the right place.
Yes.
So if you can automate the picking of parts off a laser cell and place them in an order in a nice neat stack in the same place every time, it facilitates the next downstream process because somebody's not re-racking the parts, the automation. So automation kind of chases automation. If you automate something, it makes it much easier if you can restack to automate the next thing to automate the next thing. And if you interrupt that and they become uncontrolled, and then it's an adventure.
Yep.
Absolutely. A lot of decisions.
Absolutely right. And then here's just a single hit process. You can picture someone, a temp probably, that was on a fryer on Friday, working this press on a Monday. They got their headphones in and they're just putting parts in. And it's really easy for them to make 100 bad parts because they didn't put the parts seated properly, or pick 1,000 different reasons they can make a bad part. So these folks use the collaborative robots to really make sure that process was perfect every single time. And so we've been making a long story very long. So I want to make sure that I at least mention, because I talked about AI. And when I talk about physical AI, what I'm talking about is bringing artificial intelligence to the real world, to the plant floor, in the shop, on machines. And this is really important because in the past, you remember Industry 4.0, right? Industry 4.0, there's Industry 5.0 now, and smart manufacturing and IoTs and all that stuff. And the trick about Industry 4.0 is that came from a German government initiative trying to push manufacturers in a certain direction. Smart manufacturing came from think tanks that were trying to push manufacturers in a certain direction. And I think why AI is so particularly interesting in manufacturing is because this is coming from manufacturers. This is coming from the industry. And so I think that's why it's being applied so quickly and with real applications in real ways. It's not a government program or a think tank's idea.
Being adopted because it's clearly a good idea.
Right.
No one's waiting around for instructions.
And the case studies are being proven by manufacturers from the beginning.
I swear that somebody had mentioned to me once that Ethernet wasn't really intended for industrial. It was, I don't know, maybe this is wrong, but they're it was so obviously a good solution. Everyone just quickly that became the standard.
Yeah.
No one had to make it a standard.
Right.
This was clearly a logical thing to make a standard, right?
And I feel like
You feel like this is happening in that direction where they're not waiting for any instructions, they're moving ahead.
absolutely, I think that's what's happening. And when you look abroad and you look at what folks are doing, I'm not just some other dude talking about AI. when I look at how people are using it, I was just recently in China. There is a camera on every robot. There is a camera on every robot, and that is not happening
And
here.
using AI processing to use that data to do whatever they're tasked.
Yeah, to create robot paths, to create process paths.
Right.
I mean, they are really embracing automation in a way and bringing AI to automation in ways that we haven't seen yet here in the United States, except for in very rare cases. And so AI is here and in manufacturing. You just may not have seen it. I think that's the hardest part of AI. Think back to the Harry Potter picture, right? 2022, that picture didn't look like Harry Potter at all. July of 25, we're making Harry Potter on a punch press in 20 seconds.
20 seconds, right?
And so that's really like how fast it's moving. We can't keep up with that. And so we have to just keep looking at the industry and see what's going on. And so that's why I'm bringing it up, because it's real. It's not just a buzzword. All those previous things I'm going to fully acknowledge. I have Industry 4.0 presentations in my repertoire, but this is a real topic now and something people are really doing.
Well, the ability to take the photographic images from, we talked about before, like cameras.
Yep.
Anytime you use a camera, there's a lot of caveats. Well, the lighting, and then I got it shiny and all this
Oh,
stuff.
yeah.
We can take that same camera and use the data and interpret it better with AI.
Mhm.
It becomes a much more usable scan tool.
Oh yeah, definitely. And the cameras are doing crazy things. Quality control and inspection. They're doing. I've seen die wear as an application with the camera. Press tending, bin picking, dunnage picking, and then all kinds of different collaborative applications. But to your point, I think we all need to go to machine vision anonymous. You know, when I bring up a machine vision camera, I bet half the audience rolled their eyes and was like, "Oh no, another guy trying to get me to buy a vision system." I know Ben was like, right? I mean,
fought
like,
this battle before.
right, yeah. I mean, we've all had a really failed machine vision application in the past. So I think what we have to recognize is it's advancing so fast. The capabilities of image processing is advancing so fast that we all need to take a serious look at our opinions on this and revisit them today, and even revisit them 3 months from now, because the technology is moving so fast in this image processing, imaging kind of area. And so we're not, you know, it used to be about how high end a camera could you get. And now, honestly, it's kind of sliding the other way. Yeah, even if you have kind of a low budget camera, you can do really cool things with the algorithms. And so I think we have to just totally, I'm asking you to go find your social group or your therapy group and talk through your issues with machine vision, because you're going to need it very, very quickly. You need to get past that. And so here's an example of quality inspection. This is at one of our customers. They have a Keyence laser scanner. They're passing it over the part. They're doing hundreds of points of inspection in seconds. And being able to do that used to take hours for an individual to go through and measure and inspect all those things. And then I want to point out, this doesn't have anything to do with robots at all, but some of the simpler things you could do is just put sensors on devices like motors and gearboxes on your outfeed conveyor or your scrap conveyor. This can shut down your production just for a simple motor that no one heard or saw. You know, monitoring vibration or temperature can give high value and high feedback to, oh, we need to go take care of this before it becomes a major problem. And so
Predictive maintenance becomes, it's without AI is a fool's errand. There's billions of points of data streaming across, and after it crashes, you can go back and see, oh, I see where it got worse and then where it blew up. So to be able to scan that much information real time and point out the anomalies, hey, one of these things is not like the others. I think,
Especially if there's fewer people working on the floor who are ready to catch some of these things, whether they're listening or watching.
great point, Brad. I go to a lot of stampers where they may have one person running 2 or 3 presses, right? They get it going, then they go get the other one going, and then they come back and check it out. But they may not be standing right there to hear that something's going on. And so, especially on a little motor or something, that might just be right there. So they would hear it if they were an operator, but they're not going to hear it 2 presses away.
Right.
So this is an opportunity, a very simple way for us to take physical data from the real world and run it through AI algorithms. And Google has some really nice free algorithms if you just want to try it and see how it goes. They have some really nice manufacturing algorithms for this specific kind of application. And then I have to point this out, this is a real part in a real automotive plant that's being picked. And this is a Kian's bin picking application. You can see the part's round, it's got a special orientation. And this application used to just be a person sitting, pulling parts out of the bin, putting them on a conveyor to go into regular automation, and go into traditional automation. And that job is boring, dull, all the things we said we got to get rid of. But AI
And challenging.
and challenging.
Getting that part
Yes.
and orienting it properly in the die is boring for a person, but it's painfully difficult for most automation. Until recently, you're gonna tell me right now.
2 years ago.
Yeah.
12 months ago, if you had told me that we could do this application, I would have told you you were crazy. Like, really, I would have told you you were crazy. But I have seen part after part done with this technology, this 3D bin picking technology. There's multiple different folks that are doing this now. I was at Automatica a couple weeks ago, and I bet I saw 30 different companies all doing this like reliably on point over and over again. So like, what was possible 12 months ago? Or what wasn't possible 12 months ago is very possible today, is what I'm trying to get you to see.
The price points are dropping too, because we looked into this hard, this was a need for one of our, we've had multiple clients, we're like, I'd really like to be able to automate these functions. Like, well, how many million of these parts are you gonna make a year? I'm like, 700. And then 600 of this one, 1,400 of that one, 1,400 of the, and they give me this incredibly wide number of parts with, wide mix, low volume.
Yep.
And they're all over the map in size from a piece of paper down to a quarter.
And you
It's
could
like-
have never done that.
It's like, okay, it's easy to get a person to do that and at the time I started asking hard, we found a way to do it. It was no problem. Except for that part where no one would ever spend the money on it.
Right.
And so you're saying the price points have been dropped.
Yes, absolutely. And
Oh,
the
that's
price
really-
points are.
Really encouraging.
And then I have to point out, finishing and grinding has been a tough application to automate over the years, and AI is also changing that dramatically. This is a company, Cohesive Robotics, and they're using AI tools to generate the path planning and make sure that the finishing process is the same on each part. And so that's just more and more examples, not to just show you where real AI is being utilized in many applications. I mean, I told you about when I was in China, I saw AI being utilized in welding all over the place in combination with cameras and software. So it's there. I want to just share a few more slides. I know we've kind of run a little long, but this is from EY, and robotic automation can be complex. And if we don't think through, they have 12, I think, 10 common issues in failed projects. Things like, probably you didn't think to include IT, but to your point, Ethernet's on everything now, right? And so if you got Ethernet, you got to make sure IT is in the meeting.
We have support via the internet.
Yeah.
Without IT's help,
Right? I mean, so all of these things, making sure you have the right people with the right skills to support the equipment once it's yours. I mean, these are all pieces that have caused issues and caused 50%, 40 to 50% of projects to fail in their analysis. And so
I've had one of our clients really smartly, we did a large automation project. And they created a new job position, and they took, like 2 of the guys were maintenance technicians. And one was like one of the very best lead men setup people they had. And they moved them into a role where every shift had one person who was thoroughly trained in all this automated cell. And they were their subject matter expert.
Yeah.
And they had hard skill backgrounds that were relevant. And so they worked between production and engineering, right? They were in this little, they had their very tech savvy, very, focused on this. They understood what they're doing. They understood the process. But they didn't walk on carpeting, right? You know what I mean? There was this level in between that facilitated a lot of issues, and wasn't like, well, we're down till tomorrow because John doesn't come in till 7. So we're gonna wait for the guy, with a computer. Like, and also they had so that was one of the things they very consciously did. They added to their cost the elevation, the creation of the 3 positions, right? But their deployment was very good because of it. Yeah, it was a great experience.
we talk a lot about UR. I don't have it in this report or this presentation, but we talk a lot of times when people start with the Universal Robots cobot, it's their first automation. And so
So friendly and easy to use, so people start with it. Right?
It's their first automation. And we can tell if someone's assigned a champion, the chance of success of that automation is much, much higher than if everyone will figure it out, or like, well, the engineers will take care of it. then the chance of success, there's a higher risk there. And
There's a
so
lonely dusty robot in the corner because
that
no one
happens.
knows.
Yeah.
Sure.
I mean, not one UR has ever been like that, but
It
yeah.
has that element, right?
Yeah, yeah.
Well, I mean, you gotta
But-
use the tool, you gotta provide the training, you gotta provide the people, and
Gee.
if you do it, it works. If you
Yeah.
don't, they're gonna struggle.
So, yeah, so assign a champion, I think, is a really good piece of advice, and I double down on that. That's a great point, Todd.
Tell me about number 3, underestimating what happens after automation. What's the point of that?
Yeah, I think, you know, I don't have that in here either, but, you know, what happens in your automation? Automation just makes more faster, right? And so to the point of the lasers got faster, so now we're making a lot more parts, but it still takes a lot of time to palletize the parts.
Okay.
So a lot of folks don't like. if we-
Holistic approach to
You
the
gotta
whole.
look at the whole process from start to finish of the part. It's not just the one process that
So
you
you're
want
not
to
just
automate.
moving a bottleneck.
Another thing, you know, it's like, we've had this happen both with servo progressive guys. We employ these big, either straight sides, or in the case we automate them, but it's funny in automation, it doesn't look as fast
Mm-mm.
when you put a stopwatch on it for a second. But over the course of hours, throughput's always higher. Sure. It just never stops. Sure. And so assigning like another half material handler, like anticipating like this stuff might actually work. So if it actually works, we have to bring more parts here. We have to get more parts away. And if I put an automation cell in that like efficiently runs it through, but we're starving it because we can't get blanks to the front end, or we have no place to put the parts. Now, the automation project didn't work because it affects everything on either side of it.
Yeah.
Right, so you actually like, well, what if this actually does what that guy Will said it would do? Like, what are we gonna do? You know?
Got a couple of angry calls. Welding is my passion. So I joined UR to do welding and sell welding. And people bought the automation doubled or tripled their production value. And then months later, the owner called me. This thing sucks. It's using way more gas and way more wire than the manual welders were. Well, of course it is. You
So
have three times as much
yeah,
production.
Yeah, it's using
So,
3 times.
yes, so you're using 3 times as much wire and gas. So I think
Absolutely.
thinking about the whole situation, and if you're gonna be 3 times as much, do you have 3 times as many blanks? And how do you have 3 times as much gas?
You haven't made enough way. How
Do you
get
have enough,
parts away?
do you have enough fluid to run in the press that you're ordering weekly or whatever it is? So, you know, there's all these pieces and parts that come together, I think, that, that's why it's so
It's like
important.
an act of faith, you know, but if people don't, if it's easier to do the justification of just this piece, but in the real world, the material handling about it matters. And you have to factor that cost in as part of your ROI calculation. This is a major factor in whether it's actually gonna produce the result you want. Right, so it's funny, it's a lot of our job is looking at stuff that people are, tell me about this cool machine. I'm like, yes, it's really nice. How big is your biggest fork truck? What? Can your tool room handle the new die? Where are these parts going? Well, that automated cell that you saw a picture of. And they were gonna, well, we'll just drop everything scrap into tubs inside. We'll open up this gate, we'll go get it. I'm like, no. How about this? If we have to be an outside wall, I said, why don't we punch a hole in the wall and convey it out? They're like, that's an awesome idea. Right? Because the throughput would have been so high. Without it, they would have been spending a lot of time on, now, it still would have been faster, but we'd have lost throughput due to material handling. Right? So scrap isn't very sexy, but it matters.
So to that point, I think, you know, when I look at successful automation deployments and so much work has to happen before you actually deploy it. So going out and buying a robot or painting stripes on your Cartesian robot, before you get all excited about it, it's really important to build the right foundation, right? You have to have a project team, make sure the IT guy's there, make sure that you have, you know, operators. Operators know your production better than anybody.
I'm gonna call maintenance. So
Yep.
Yeah, they know what's going on. That's a really important
Maintenance,
piece, right?
absolutely. Who's gonna support it? And who knows that equipment? Do they know that technology? You know, outlining a clear scope of work, and the clear scope of work, when you go in and talk, we always talk about what's upfeed, how the part's gonna get there, and what's downfeed, where do the parts need to go, and what's gonna happen with the parts after that. And to me, I highly encourage anyone, especially if you're new to automation or you haven't automated much, even if you've automated a lot, work with an integrator, work with someone who knows, someone who can help you with selecting the technology and look at your scope of work. And then, you know, go out and measure that success beyond just the productivity ROI to all those soft things that we've talked about. So I'm gonna say there are lots of stakeholders when you're building that team. I just want to make sure I point this one out and just say, there are lots of ways to get help doing this, especially if you're small to medium size. You're thinking, I would love to automate, I don't have time. Your state has something called an MEP. If you don't know what an MEP is, this is a local organization stood up by the US government to help you work through automation or cybersecurity or workforce challenges. They are there and they have windows into funding or windows into ideas of how you can do these projects, or might know local integrators who can help you. Some even have dollars that they can help with your automation investment. University innovation hubs are really powerful. There's a lot of researchers and folks. There's one at Cincinnati. I'm showing you the Cincinnati State research hub here where there's a lot of investment and opportunity. They're building this to support the local manufacturing community and the local industry. And then last but not least, PMA. I mean, if you're not a PMA member, the Precision Metal Forming Association has lots of education tools that are at a good price for you and for your employees. They've got advice and folks who can help you figure out and navigate how do we get automation and how do we get our workforce trained for the automation. And so don't do this by yourself, please. If I had a theme, you know, and I'm not trying to insult you, this is my last slide, but your process and your problems aren't unique. And so please don't work alone. That's really what I'm asking you is there are folks out in the industry who have done, if not your exact process, something similar that they can leverage their knowledge to help you. And that's really my call to action. Go find someone who can help you do this. And if you don't know who, find me on LinkedIn and I'll help connect you with someone who can do that.
Fantastic. Well, thanks so much, fellas, for really engaging conversation. I thought it was really informative, and I hope our audience out there found it equally informative and interesting. The event is recorded and will be archived on our website if you want to watch it again or share it with anybody else at your company. So again, thank you all. Thank all of our attendees for joining us today. And I want to thank our sponsors, NEDEC, Wilson Tool, and Principal Financial before we go. So thanks again, and zoom in on Will's hat. We'll see everybody at FabTech, and we can continue the conversation there. So we'll see you in Chicago in a couple of months at FabTech. Thanks again for joining us today.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass, move along.